Okay, guys, you obviously are not going to have to redraw the diagram, so you can just write maybe like next to it on the next page, or you just type this in 1A. Okay, you might want to make some notes on the actual picture. I'll show you whatever notes I'm making, you can also make. But this is now actually like the application of all the knowledge that we've done so far. Okay, so we've done drawing the different graphs, we've done finding the equations of the different graphs. Now we need to be prepared for them to give us graphs and us to then answer questions. Okay, we've done a bit of it so far. We've done domain and range, which is something that they often ask, and we have looked at the axis of symmetry of a parabola. So we remember where that is at the x value of the turning point. Okay, so we looked at that, and then the axis of symmetry or axes of symmetry of a hyperbola. Remember, there are those two. All right, the positive and the negative one. So those are already examples of questions that they can ask you that are kind of interpretation questions. Okay, now for this first one, they're saying the sketch shows the graphs of y, which is f of x. Now guys, if you're looking at the picture, I think they didn't actually label that one, but they did label g of x. Sorry, it's quite unclear there, but I think you can see better on your page. So do you see that y equals g of x is a straight line? Okay, it's there at the top arrow. Okay, so it's not very clear. Maybe you just want to put a G there and then an F. If the straight line is G, then I think we said to assume that X will be the parabola. But they're not even giving us the equations of these two graphs, right? They're just saying that we have a graph that's labeled X and a graph that's labeled G. Use the sketch to find the values of X for which, and then they're asking us various questions. Guys, are they stating find the equations of these graphs? No. What did they ask us to? Right? Let's look at what they gave us here. For the straight line, they have given us the y-intercept is 2 of the straight line. Okay? And then they've given us another point, actually two other points, the x-intercept and another point. So we could find the equation of that graph, but they're not asking us to, so we're not going to even spend time on that. Then for x, what have they given us here? They've given us the two x-intercepts, you guys see. So we could use x-intercept for that, right? That one is -2, so we'll say x plus 2 in that bracket. And the other one is 6, so we'll say x minus 6 in that bracket. And then what do I have to do to find the equation of a? Sorry, the value of a. Remember, a is in front of those two brackets. Sub in another point, hey. Now, do we have another point on the parabola? A point that's not one of these two that we've already used. We actually have three, hey? We have the point 8, yes. We have the turning point 2, -8. And look at that one. We have 0, -2. Alright, so you could potentially sub in one of those 3 points, and you will get the same answer. Okay, if they ask you to find the schedule. They're not asking us to find that 0, so we're not going to. What they are asking us in the first question is we must give values of x. Now guys, I want you please to highlight that. That's very important. Values of x. So our answers are going to have to be x is greater than this, or x is smaller than this, or x is between this and this. Alright, if we're saying the values of x, we're going to have to give only x values in our answer. But now we're saying for which x is greater than 0. Greater than 0 means positive, right? So let's add that in. But the fact that they use f of x is important for two reasons. First, it's telling us which graph to look at. Okay, f is which graph? The parabola. So to answer this question, we need to look at the parabola. Okay, but also what is f of x? What can I replace f of x with? F of x actually means y. Alright, so they're asking us for which values of x of the y values, because we're saying f of x, so the y values of the parabola and now instead of just saying positive, we know it is positive, right? They've said greater than 0. But let's quickly think, what does that mean? If a y value is positive, if I'm looking at the graph, what values do I have here? It's 0, and then which y values will I have over here? Positive or negative? Positive. And what about down here? Negative. So instead of using the word positive, I can actually say above the x-axis. This is the x-axis, right? All those values up there will be positive y values. Okay, so instead of writing positive again, I'm going to say for which values of x are the y values of the parabola above the x-axis. You can highlight here that the word positive and above the x-axis. We're talking about y values, they mean the same thing. Because the y values that are above the x-axis are always positive y values. Okay, so that's what we're going to look for, right? But then our answer has to be x's. Okay, so we're looking at y's, because we must write down x. So let's take a look. We're looking at it. All right, so try and just ignore the straight line for now. This question has nothing to do with the straight line. Guys, do we agree that this part is above the x-axis? Sorry, there is a bit of an overlap there. Let me just erase it. Okay, that part. And this part here is also above the x-axis. Right? Guys, if you have to read off the y values of every single point on this highlighted part, they would all be positive. What if I'm looking at this point over here? You don't have to put this in, but if I'm looking at that point over there, it's perfectly in line with that point. That will have a y value of 2, which is positive, right? Above it, somewhere you'll have a y value of 3 and 4 and 5, all positive y values. Okay, same thing over here. All of the points, remember on a graph, they actually have an infinite number of points. Okay, we're just going up the crossing. On this pink part here, every single point on this highlighted part will have a positive y value. Right? Because they are all on the positive side of the y-axis. All of these values here are positive. If they asked for negative, we would be looking at the part that is below the x-axis. Okay, since they asked for positive, those are the parts with y values that are positive. Does it look familiar, guys? Remember when we did quadratic inequalities and we drew a little parabola? And when the question was saying positive, we used to actually circle it like this. I did something like this earlier. That part and that part. Right? Do you remember? It's basically the same thing that we're doing now. Okay. We're looking for the positive part. So the part above the x-axis. Now the tricky part comes in where we have to write our answer. Okay, because what we've highlighted here, unfortunately, they're not going to mark. We need to now write in mathematical terms which x values will be on this pink part and which x value will be on that pink part. Now, what do we think, guys? What is the x value of this point here? You see that it's -2. Okay. Now, am I looking at, I'm looking at the pink part, are those x values to the left of -2 or to the right? To the left. So are they smaller than -2 or greater than -2? Smaller. So that's what I'm going to write, guys. I'm going to say x smaller than -2. That represents that first pink part. And I'm going to say equal to -2. In the question, they're not putting it equal to 0. Okay. If I wanted to include -2, what's actually happening at -2, guys? Y is 0. Okay, at that point. So I'm not including that point. But that's not the only pink part that we highlighted. We also highlighted this part, so we have to say or. I'm just putting it underneath because I don't have enough space next to it. Okay, you would write it next to it if you have space. Otherwise, you can write it underneath. Now we need to say, in terms of our x values, what x values do we have on this pink part? So we again looking at this point, guys. See? Now the highlighted part is it to the left or to the right of 6? To the right. So smaller than 6 or greater than 6? Greater, right? We'll have 7 and 8 and 9, blah, blah, blah. So x greater than 6. And that's the answer to the first. Any questions on that?
You wouldn't say that.
No, you wouldn't say and because it's two separate parts. Okay, so you can't have the value on this half and that one at the same. Okay, that's what you have. Exactly. Okay, any other questions? Yes. So you can only do that if it's representing one area. So if it was negative, if you were writing for this part, then you would say -2. Okay, then if the x is in the middle, it literally means x has to be between those. Okay, so that means two separate parts. You have to write two separate segments. Okay, if one part, you write one segment. Yes, again? Yes. There's not really possible. Oh, it's actually my. Okay, let's look at the next one, guys. I like the fact that you're asking questions. Nice. Okay, the next one is saying, same thing for which, find the values of x for which. Now they're saying g of x must be greater than f of x. So now they're actually comparing two graphs with each other. Okay, so g we said was the straight line and f is a parabola. So guys, they're saying the y values of g. The y values of g must be greater than, what's happening there? Are we on a video call? Must be greater than the y values of x. Okay, that's what they're saying. Because remember guys, g of x and f of x, that means x. Sorry, y. G of x and f of x, that means y. But they're using g and x so we know which graphs to look at. That's why they're not just saying y must be greater than y. They're saying which graph is which. So guys, what that means, if we don't want to actually use like the symbols, we just want to speak in English about this, we're going to say, where is G? Where is the straight line? Higher up, right? Greater than. Higher up along the y-axis than the parabola. Okay, so I'm going to write straight line because that is what G is. Straight line. Higher up. Or actually, let's say above. That's better English. Straight line above the parabola. So now we're not looking at the axis anymore. We're now actually looking at the one graph versus the other. And then again, our answer will be right the x line. Let's take a look at the graph. Guys, I suggest that you just start at the beginning and you work your way through, all right? Which one here is higher up? The parabola or the straight line? The parabola, right? They're saying the straight line must be greater than, so higher, so above the parabola. So here, all the way, if we're looking at the y values of any point of the parabola here versus the y values on the straight line, so we agree that these y values would be bigger than these y. Right? Because this is like a positive one, that's even a negative one. Okay. What happens at this point? at negative 2, 0. They both have the same y value, right? Which is 0. Okay, so this we would call the point of intersection if they are that. Okay. Now after that point, which graph is now above the other one? You see, G, the straight line here is above the parabola. So it's this section, guys. And what happens? All the way, C straight line above parabola, above. There at that point, they are equal again. And then after that point, now the parabola again is above the straight line. Okay, so it's this section that we're looking at. Okay, between those two values. Now, guys, because this is now one section, we're now going to write one section. Okay, we're going to say x is between negative 2 and 8. Right? You see that x value at this point is 8. So x is now going to be between negative 2, that's the x value of that point, and 8, which is the x value of that. So we can write it like this, negative 2, and then we put our x in the middle, and then our 8. Here. Again, I'm not putting the line underneath because they didn't put it in the page. Right? They didn't say we must these graphs be equal as well, so we're not going to say equal here. Now, if you want to write it in interval notation rather, you can say x is an element of negative 2 to 8. And we would use round brackets so that we put those values on it. Okay, are we ready for the next one? So guys, the next one is a question that often comes up in tests and exams because it's a bit of an application question and you need some number knowledge for this as well. So they're saying here, the graph of x multiplied by the graph of g must be positive. Okay, so let's first just write that that must be positive, right? Greater than 0 means positive. Now guys, you can't see, if you're looking at the graph, you can't see like an actual value for one graph multiplied by another graph, right? There's no way of seeing that. Okay, and how do you times a graph by another graph? That's not really clear. So what we need to think now, remember, f of x means y value of x times g of x again means the y value of g, right? Okay, so the y value of x multiplied by the y value of g must be positive. So guys, if we think it would be a y value of a point with a number, right? And the y value of a point on another graph is also a number. So let's quickly think, what types of numbers must I have so that if I'm multiplying together, my answer is positive? Either two negatives or two positives. And that is the thing to this question. All right. So I'm going to write, therefore, they must both be positive or both negative. And that is actually what we're going to look for on the graphs. We're going to look for places where the two graphs are both positive or they are both negative. Now, how do we figure out or how do we look for where a graph is positive again? What did we look during the first question? We look for where the graph is above the x-axis, above the x-axis. Okay, so we can further simplify this by saying both above x-axis or Now, guys, positive is above the x-axis and negative is going to be below the x-axis. Okay, so if they're both above the x-axis or they are both below the x-axis, then we know that if we take those y values and multiply them together, the answer would be positive. So guys, we're not really thinking of graph times graph, right? We're actually thinking y value of a point on a graph multiplied by y value of a point on other graph. So we're literally looking for where is, erase this quickly, where are both graphs, sorry, well, English, where are both graphs positive at the same time? So where are both of them above the x-axis? Now, if we look at this, guys, what's happening here? The parabola is above the x-axis, but the straight line is below the x-axis. So all of these y values would be positive numbers. All of these y values would be negative numbers. What do I get if I do a positive times a negative? The answer is negative. That's not what they asked, right? They asked for positive. So I'm not going to include this section in my answer. Okay, what's happening here? Now the straight line is positive, right? And the parabola is negative. So if you take a positive number multiplied by a negative number, it will get negative. And that carries on, guys, for quite some time. But now look at this. Let me quickly put a line here for you so that you can see. If I draw a line there, maybe a dotted line is good. So I'm trying to make this line. And then make a dotted quickly. So that's too distracting. You can also put it in on your graph if you want, because this is the last question that we're doing on these two graphs. You guys see that after this point, right? Because up until this point, which is at 6, 0, the parabola is negative and the straight line is positive. Now at this point, what happens? The parabola is 0, right? And then after that point, the parabola is positive and the straight line is positive. You see that? And what's happening further on? They're both positive, right? Is the parabola going to turn around and come back down? No. Is the straight line going to make like a little triangle and come back down? No. So to infinity, these two graphs are both going to be positive. All right. So how will I write that, guys? From which x value is this happening onwards? From x equals 6. Well, actually, x greater than 6. Hey, not even important. But from this point. So we're going to say x greater than 6. And that's the answer. Okay. Or like I said in the previous one, if you want to, you can write it in interval notation. Then you would just say from 6 to infinity. Now for this question, there actually wasn't any place where they were both negative at the same time, right? So they were both below the x-axis. That's why this answer only has one section. Okay, but just be aware, guys, sometimes there will be multiple parts to this answer. Okay, so multiple sections. Then you'll just do what we did in the first question. You'll just say the one section or the other section. Okay, whenever there are multiple sections, you just have to listen. Does that make sense, guys? Now, again, if they ask for negative here, what two numbers would you multiply together to get a negative answer? A positive and a negative, hey. So then you would look for places where the one graph is above the x-axis and the other one below the x-axis. Okay, and then you would write that down. It will probably come up in the relatively like that. Right, any questions on question 1, guys? Okay. Question 2 is quite a nice question. It's just working with transformation. Now you haven't really looked at transformation specifically, like as a section C straight line. The actual topic is out of the syllabus, but we need to be able to apply it, especially in function. Okay, so they're saying for number 2, consider the function f of x, which is x squared minus 8x plus 7. Guys, what type of function is that? What do you guys think? Parabola, right? How do I know that? Because of the x squared. Okay, it doesn't actually matter in this case, but we can just write that there. Just as a reminder, we are looking at a parabola in this case. Oh, sorry. Now we say, and the wording of this question I didn't love because it sounds very complicated, but I thought let me write it down as it was because we can talk about what they're actually asking. Determine the equation of the graph which this function would represent if. Now, what they mean by that is if you're looking at this function, you can draw it as a graph, right? A parabola. So basically, they're just asking for the new equation of a graph. If they're taking this graph and now they change it. Okay, so what are they saying? If A, the graph is moved down 2 units. Now guys, whenever you are moving down any graph, it can be a straight line, a parabola, a hyperbola, or an exponential graph. When you're moving the graph down or up, what changes is the constant term. Okay? I'm going to write that there. When you're moving up or down, we're going to do one at the bottom where there's or C is one with up. Okay, so I'll write a note there. So when you're moving down 2 units, all you're going to do is you are going to minus 2 from the, we can say constant term, but actually from the whole equation. All right, so I'm going to say minus 2 from the equation. So that's all you need to remember, guys. If it's moving down, we'll just minus 2 from the whole equation. Okay, so the equation that we started with was, I'm going to write it again, f of x was x squared minus 8x plus 7. We are now moving that graph, that function down 2 units. So now you can say then, now guys, we can't say f of x again. Okay, because it's not f of x. No, it's a new graph. We don't know what the name of this new graph is, so we're just going to say y. Usually they do give a new name for the question. They'll say, find the equation of h if h is x moved down to. Okay, so if they did that, you would write h of. Okay, they didn't give us a name here, so we're just going to write y. So we're going to take the whole equation, guys, exactly as it is. So all 3 of those terms, but now it's moving down 2 units, so we're literally just going to say minus 2. And then we must simplify. Okay, we can't leave a 7 minus 2 like that. So we're going to say x squared minus 8x plus 5. Okay, so move down 2 units. That is what we're doing for that. We are literally just minusing 2 from the equation. So if you get that as a question, you can be very happy because that will be a 1 marker, but it's a B. Okay, 1 mark for that. So that you can actually just go straight to plus 5 if you just do the 7 minus 2 and 1. Right, so this is a marker. Okay, next one. Are there any questions on this one? Okay, next one. The graph is moved 1 unit to the right. Now guys, when we did moving to the right with true graphs, you remember how we actually showed that in the equation. To the right is in the positive direction, right? So we put a minus. Maybe you guys remember when we did like moving 50 degrees to the right? Then we would say x minus 50. So basically, guys, when you are doing a movement to the right or the left, you're going to put it in an x bracket. Okay, so we're going to write a note on that. movement to the right or left. Now, because we're moving 1 unit to the right, which is in the positive direction, we're going to have to put an x minus 1, right? Remember the x bracket is always different sign from what's actually happening. So because it's to the right, which is the positive direction, therefore, what's actually going to happen is in the equation that we have, x is going to become x minus 1. Okay. Just like with three graphs, whenever we move 30 degrees to the right, we put in our bracket x minus 30. And it's the exact same concept here. We are moving the whole graph 1 unit to the right. So wherever we have x in our equation, we're going to change that now to x minus 1. Okay, so what we're going to do, I'm just going to rewrite f of x again. I think I'll do that every time so that we just know what we're looking at. F of x is x squared minus 8x plus 7. And I've made two x's in this equation. Both of those x's are going to become x minus 1. Okay, so we're going to say then y is equal to, instead of x squared, we're going to have x minus 1 squared minus 8 times, instead of x, we're going to have x minus 1. And then plus 7. Now, guys, unfortunately, this is not a form of a parabola equation, right? That's not quite turning point form, not quite standard. So we're going to have to multiply these brackets off. Okay, which is going to take a while, but it's okay. So x minus 1 squared, I suggest that you just write that as x minus 1, and then we're going to FOIL it out. But the negative 8 we can multiply into that bracket so long. I'm going to say negative 8x. And then negative 8 times negative 1 is plus 8. Plus 7, which we can simplify, right? We can add those two. But when we FOIL this out, we are going to get a constant term as well. So I'm just going to do that quickly. X times x is x squared. When you do your outers, x times negative 1 is negative x. Your inners, negative 1 times x again is negative x. And then negative 1 times negative 1 is plus 1. And then we have all the other stuff that we've had already. I'm just going to simplify this to 15, right? Is that fine? X plus 7 is 15. And then we need to simplify the whole thing. So we have a negative x minus x, that's negative 2x. And then minus another 8x, that's negative 3, right? And then 1 plus 15 is 6. Okay, so that's the final answer. Now, guys, it looks like a very complicated question, but most of this was just actually multiplying out and simplifying, right? So if you were thinking in terms of mark allocation here, you'll get a mark just for replacing each x with an x minus 1. That will be your first mark. Then they'll give you a mark for FOILing out here and probably 1 mark for simplifying. Okay, so they do view this as kind of grade 9 level algebra, so they won't give a lot of marks for that, but you will get some. Yeah. Yes, exactly. We're going to do that now. So you always put the sign must always be in the opposite sign to the direction. It has to do with if you are coming in. Sure, it's actually quite a complicated explanation. If you are looking at of what example I can use to explain that. If you are doing, if you do, let's go to another page, please. If we're doing the graph of y equals, and now we're doing the graph of y equals x squared, right? Versus graph of y equals x minus 1 squared. Let's do a +3 actually, and a +3, so that's a bit more realistic. If you just want to think of the turning points of these graphs, right? This is definitely written in turning point form. So the turning point of this graph is going to be 1 and 3, right? But the turning point of this graph is going to be 0 and 3. So if you're just thinking in terms of the turning point, they will have exactly the same shape because it's the thing that affects the shape of a parabola is your a value, right? And in these two equations, they both have an a value. So they'll have exactly the same shape. It's just in terms of the turning point. If you compare the turning point, you can see the shift quite nicely. So here, how do you, like, in what direction must you move to go from 0 to 1? You're moving to the right. Okay, even though there's an x minus 1. Correct. Another way, I went to a workshop once and the instructor also gave us a way of explaining it, but I thought it was a bit complicated. But if you wanted the same point, so say I want the same x value, the same y value from this equation and from this equation, right? So if I want y equals 3 from this equation, then what must I sub in? X must be what for me to get the same y value? X is going to have to be 1 for me to get the same y value of 3, which means I need to sub in an x value that is 1 unit to the right of the x value that I subbed in. Okay, how does that make sense? Sorry, I wasn't prepared for that explanation. Okay, now for C, which is where I just put the two types of stuff together. So this one is now saying, sorry, let me just move this one line down. So now they're saying the graph is moved 3 units up and 2 units to the left, right? So now we need to combine these two concepts. Okay, when you're moving 3 units up, you just add 3 to the whole equation. But also we are now moving 2 units to the left, right? So x is going to become x. If we're moving to the left, it's into the negative direction, right? So it's going to become x plus 2. So that's two things that need to happen, guys. The 3 units up means that I'm going to add 3 to the equation. And 2 units to the left means that x is going to become x plus 2. Okay, because the left is negative direction, so we put a plus in that bracket. Okay, and we're going to do that at the same time. To do those two changes. Again, I'm just going to rewrite the equation as it is given. Okay, so f of x is that same equation, x squared minus 8x plus 7. So now, again, we must just use y. They can give us a name for the graph. So we use y. Instead of x, I'm now going to write x plus 2 squared minus 8 bracket x plus 2. And then plus that 7 that I had already, but now we're also moving 3 up, so we must add 3 to the 8. Okay, now we must again do the whole multiplying out and simplifying things. So we have our x plus 2, x plus 2. I'm going to multiply that negative 8 in so long. So negative 8 times x is negative 8x. Negative 8 times 2 is minus 16. And what's this? 7 plus 3 is 10, right? So we can simplify that a lot. X times x is x squared. So I'm pulling those two brackets out now. Then we do the outward. X times 2, that's 2x. The inners is also 2 times x, that's also 2x. And then last, 2 times 2, which is 4. Minus 8x. Let's simplify this one out. What's negative 6 plus 10? Negative 6. And now finally, we can simplify this equation. So we have our x squared, and then we have 2x plus 2x is 4x. Minus 8x is negative 4x. And then we have 4 minus 6, which is negative 3. Alright, so that is okay, guys, we will do D and E and number 3 tomorrow. Yeah, it's fine. I'm not graduating now. I would like you to spend some time this afternoon, like starting to prepare for your test. I know it feels like it's very far, but it's tomorrow in a week's time. But remember, you don't have school on Monday and Tuesday. So once you get into the long weekend, it's probably not going to feel like work. But it's maybe a good idea just to come practice going as you drops. Oh, actually, I did want to show you guys the thing do that now. It's kind of get there. And if you are able to use your phones if you have data, then you can get that out quickly. So I just want to show you guys a website that has very nice practice. And it's all free.